Alright guys, so we're going to take a look at section 4.3, talking about the line of best fit, or the regression line, that there are kind of different names we can call it. Essentially what's going on is we have our scatter plot, and now we're going to go ahead and we're going to draw the line through the middle of it, the line that kind of best summarizes all the data. We've kind of been talking about drawing the line. Now we're kind of actually going to draw it and kind of look at the equation of the line and see what it means. So the one that I like, the example that I like, is on page 148. It talks about they got a sample of a bunch of people's cars, and they took the age of the car going across the bottom here, and then the value of the car going across the top. And it looks like what we got here is that as the age of the car increases, remember here the numbers start from like 0 and go all the way up, and as the age increases, the value of the car decreases. So we have a negative trend then. So as age increases, your car is more years old, it is worth less money. So that's kind of the relationship we have here. The equation they give for us is they give us a predicted value. So our value is like our y variable. So we have age is like our x, and value the value is like our y. So that's how that works. And so this is like our y value. Our predicted value is like our y equals this 21,375 minus 1215 x is another way that we could write that. And that's the basic format for the line of best fit. Really, the way it looks in general, it looks like this: y equals a plus bx, where b is the slope of the line and a is the intercept. This should look somewhat familiar to the slope-intercept form back from college algebra, where we had the slope-intercept form of a line. We kind of changed the order around, changed the letters, but same thing's going on. That's our slope, and that's our intercept, our y-intercept. Okay, so now let's look a little closer at this line right here. So this is our line. So we kind of already talked about, okay, it has a negative trend. We see that negative trend here, where we're subtracting the slope right here. This is like our a value, this is our b value, and we're subtracting the slope. That's what gives us the negative trend up here. If this had a positive trend, we would see a plus sign right here. All right. So let's investigate this a little bit further. If we set the age equal to 0, the age is equal to 0, that would mean that the age of the car is 0 years old. That would mean the car is new, so that's a new car. So new car has an age of 0. And so like, where does that fall on the scatter plot? Age of 0. Well, age goes across this way. Age of 0 would be right here. That would be right at the y-intercept. So where this line crosses the y-axis up here, and that would be like saying, okay, the car is brand new, never come up the lot, it would be worth that much money. If we plugged in 0 into this equation and did the math, we plug in 0 right here, we would have this 21,375 minus 1215 times 0. So this term would kind of go away, and we'd be left with just this 21,375. This value right here is what the book will refer to sometimes as the initial value. It kind of starts off at this value, and then every year, as this number increases, we subtract this 1215 more and more times. If we subtract it 0 times, then we just get our original value, the original value of the car before it started to age. So let's look a little bit further into this. If we set the age equal to 1, so that the car is now 1 year old, if we plug in 1 right here, it would be our original value minus this 1215 one time. If we plug this in 2, so now our car is 2 years old, we'd plug a 2 in here, and we'd do this original value minus 1215 2 times. So what's really happening is our value of our car is decreasing by this much every year. So every time we increase by 1 year, we're decreasing the value of the car by this 1215. And that's how the slope works. The slope is as this value, this x value, whatever it is, in this case it's the age of the car, as this increases by 1, the y value, in this case the value of the car, will change by whatever the slope is. If it was positive, it would increase by it. Here it's negative, so it decreases by whatever the slope is. So that's kind of what we can see from the slope. Okay, and then for just to do a little bit of math here, a little bit of algebra, we can predict the value of the car when it's 10 years old. So all we have to do is we say, okay, so y equals 21,375 minus 1215 times 10. We do the math, so that's 21,375 minus, what's that, 12,150. And I need the calculator real fast. I don't have it on me. It's in the book. It ends up being like 9,000 something. So let me see if I can get this real fast. Hang on, let's see what we got here. Sorry about this, guys. Let me get the calculator out. That would be 21. Sorry. So 21,375 minus 12,150. Told you. 9,225. There we go. Okay, so it would be 9,225. Hopefully I did the math right on that. But so that we can say that, okay, since we saw this sampling of cars that had this relationship, we can use that information, we can use this formula now to kind of make predictions. And so we are able to predict, okay, if a car is 10 years old, we can predict that it would be about this much in value. So, so that's what's going on with that.